So how we're going to do that is hit second plus, because that's the memory. We don't need to clear the list. Wouldn't hurt, but then let's do it while we're here. Let's hit number 4. Clear all lists. Let's just get all of that out of there. And enter. And then we're going to turn off the stat plots by hitting second y equals. And number 4 turns them all off. Because if your stat plots are on, it doesn't like to graph normal stuff. It's trying to figure out how do I get all the statistic stuff on. So now we should be all set to go. Because what happens when an equation is not factorable? We know the rules to math. We never give up, and there's no crying in math. So if we're not going to give up and we can't factor it, well, we've got our fallback, that $130 calculator. That's what we're going to use. So in math, we never give up. The real roots can be found by using a graphing calculator. Now, it's not going to say find roots on it. It's going to call them zeros. And we've seen that before under second tricks. You know, it's there. It's find the zeros. So that's what we're going to do. And they're literally telling us, don't even waste your time trying to factor this. Just plop it in a calculator. But we can't plop it in a calculator if it's not equal to 0. So we do have to do a little math by hand, where we say, hey, I'm going to have to subtract 4x squared, and I'm going to have to subtract an x from both sides to make this work. So x cubed minus 4x squared minus x plus 5 equals 0. And I can't help it. I look at something like that, and I think if it is factorable, I do think I would want to do that. So I just, in my head, try to do a little factoring by grouping. If I take an x squared out of these two, I'll get x minus 4. But back here, all I would be able to pull out is a -1, and then it would be x minus 5, and they wouldn't match anymore. So I can't factor this one by grouping. I have to use my graphing calculator. X cubed minus 4x squared minus x plus 5. Let's go put it in. So y equals and x cubed, so x to the third minus 4x squared minus x plus 5. And all we need to see is where does it hit the x-axis, because that's where the zeros are. So let's try zoom 6 and see if we can find them. Okay, now this was a degree 3 polynomial, so there's supposed to be 3 places that it crosses the x-axis. Can we see all 3 places? We don't have to mess with our window because we can see it. Blinky can find them. So what we need Blinky to do is tell us what's the x value right there, and right there. Now my hope is maybe a couple of these are nice. That's like really super close to -1. That's really close to 1, 2, 3, really close to 4. So I would probably use my table first and see if there's any zeros in any of those spots. So, oops, here I am grabbing my by hand one and keeping it here. Can you see that? So second table. Oh, well, that's not good news. I don't see any zeros in any of the y's here. So maybe they looked like they were nice, but they're not. They're not. So back to the graph. And now Blinky is just going to have to tell me where these are. Now, usually this is not real tough to do, but you have to keep your mind on the fact that Blinky only knows left and right. Blinky doesn't say up and down. So if I want this red dot, I'm going to have to tell Blinky this is to the left and this is to the right. But for the next one, that's backwards. Now, this is the left side of this intersection and this is the right side. And then it goes backwards one more time for this one. You're going to know you did it wrong when Blinky says error or no sign change. You'll realize you did it upside down when that happens. So Blinky, let's get you up here. Second trace. Number 2. find the zeros. And Blinky's going to need to go below the x-axis, somewhere down there. That's close enough. So he's to the left of the intersection, and press enter. And now I need to move Blinky to the right of the intersection, so just hit Blinky up 1 or 2 times. Now he's definitely to the right of that red dot, and hit enter. And then hit enter through guess, because Blinky always wants us to take a guess, and we don't want to take a guess. So that's why it didn't show up in the table. It's not a perfect -1. It's -1.09. So go ahead and write that one down in your packet. -1.09. The others aren't perfect either, so we've got to use Blinky to find those. So we'll do second trace again. And then we're going to do the zeros, number 2. And now we've got to move Blinky so that Blinky is above and to the left of the next red dot. So that's a pretty good spot right there. And press enter. And then hit enter, hit the right arrow a couple of times, 2 or 3 times to make sure you're below it and to the right. And hit enter. And then hit enter to guess. There's another one that was not perfect. 1.16. So go ahead and write that 0 down. 1.16. One more to go. So Blinky, you're up. Second trace. Number 2. Got to get Blinky below and to the left of this intersection. Looks like a pretty good spot there. Enter. And then above and to the right. Enter. And enter through guess. Yep. Again, it's not in the table because it was really 3.93. So write down 3.93. So this one was all calculator. Nothing else we could do with this. And let me get those on there. -1.090. 1.160. And 3.930. And again, if you would prefer to just write x equals -1.09, x equals 1.16, x equals 3.93, perfectly fine. That tells me you knew what you were looking for. You're looking for where the x value will give you 0 for y. So we've got that. All right. Anybody need me to fix anything on the calculator? So far, so good? Everybody's good? Okay, then let's go after another one. This one says, what are the real solutions of this little monster? X cubed plus x squared equals x minus 1. I don't want to put that in my calculator. What do I need to do? Subtract an x and add a 1. So we'll have x cubed plus x squared minus x plus 1 equals 0. And again, I can't help it. I would want to try and do this one by hand. So I'd look at the first 2 and say, if I pulled an x squared out, I'd have x plus 1. If I pull a -1 out of this one, I'll have x minus 1. I can't do this one. I have to use my graphing calculator. So, graphing calculator time it is. And I better erase all my green and red up here for my new solutions. So, clear that little bugger out, and instead we will put in x cubed plus x squared. X to the 3rd plus x squared minus x plus 1. Little small numbers, we should be okay with 0, 6. Nothing large about that. How many solutions was it supposed to have? 3. How many do you see? 1. Well, that's because the other 2 are imaginary. Now let's read the instructions and see if that's a big deal. If we're supposed to find all of them. What are the real solutions of the equation? They only want us to be the one that we can find. They don't want the imaginaries. Good deal, because that would take us some time. So now I have to figure out that this is to the left of the intersection because my intersection is going to be my little red dot right there. And then this would be to the right. And just let Blinky take care of it. Second trace, number 2. And Blinky's a little out of position, so let's get Blinky below it. Left. Enter. Right and above. Enter. Enter your guess. Negative 1.84. That's the only real zero that we get. The other two are imaginary. Negative 1.84. When it says, just find the real ones, don't spaz out when you see, oh my gosh, there's only one and there's supposed to be 3. It's okay. Remember, imaginaries come in pairs, so the other 2 are imaginary. B says, in problem 3, which method seems to be an easier and more reliable way to find the solutions of an equation? That must mean there's another way. There is. The other way is to leave this exactly as it is, put this in as y sub 1, put this in as y sub 2, and see where they hit each other using the intersection function. So let's see if that's a little bit easier and faster. Back in y equals and clear that bugger out. And on the left side we had x cubed plus x squared. Oops, I always forget to hit the arrow button and get that out of there. So x cubed plus x squared, and then we had x minus 1 on the other side. Let's see, do they hit each other? Just going to hit graph. They do hit each other, and they hit each other at just one spot. So we should just get one answer. Let's see if it's the same answer. Second trace, number 5, and just enter, enter, enter. And let Blinky tell us where that is. Well, it's the same answer. But you know what? The part that always confuses people is, so what do I do with that? Nothing. We don't care what the y is. We just care what the x value is when they hit each other. That's what we're trying to find. So the point is, there's 2 ways to do these. If you don't want to move stuff over, you don't have to. It's just that sometimes the windows get a little weird. So it's going to be totally up to you which one you want to do. So, in problem 3, which method seems to be an easier and more reliable way to find the solutions of an equation and explain? That's an opinion problem. I mean, whichever one you like to do, do it. You know? How many of you are saying, I'll just stick with second trace because it'll say 0 and that's what it is like? Anybody that says, you know what, it was easier to do y sub 1, y sub 2 and see where they hit? And so, it doesn't matter. Either way, however you can get it, and give them the answer. So now we've got to get to the word problems. We knew it was coming at some spot here, and we've got 4 days on this section, so we haven't seen them yet. This has got to be it. We have some close friends, and they are Stacy, Una, and Amir, and they were all born on July 4th. What's the chances of that? Huh? Stacy is 1 year younger than Una. Una is 2 years younger than Amir. On July 4th, 2010, the product of their ages was 2,300 more than the sum of their ages. How old was each friend on that day? Oh my goodness. Do you know how you start this problem? No. You ask yourself, who is it I know absolutely nothing about? Amir. I know nothing about Amir's age. So Amir is going to be X. They didn't say anything about Amir's age all the way through this. Now, it said Una is 2 years younger than Amir. So what do we do to X to get Una's age? Subtract 2. Stacy is 1 year younger than Una. So what do we do to Una's age to get Stacy's age? Subtract another one, so it'll be minus 3. All right, so far we've used up all the information, close friends, blah, 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 Stacy 1 here, blah, 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 Amir. Okay, so now we're here. On July 4th, 2010, the product of their ages. What's product? Multiplying. So if we take x times x minus 2 times x minus 3, it said the product was and is in math always mean stop and set things equal to each other. Was 2,300 more than the sum of their ages. Uh-oh, what sum? Add them. X plus x minus 2 plus x minus 3 plus 2,300, because this was 2,300 more than that. Oh my gosh, look at that thing. Wow. All right, now, if you paid attention to the last one we did, you could say to yourself, I'm not doing any of this math. I am putting this in as y sub 1. I am putting this in as y sub 2, and I am going to let the calculator find the intersection of these two. But if you want a little practice on some of the other stuff that's going to be on the test, you could go back and say, well, I would FOIL these two. Then I would distribute the x. On this side, it's not going to be taking me too long. It's addition. So x plus x plus x is 3x. Negative 2 and negative 3 is negative 5. So 2,300 minus 5 would be plus 2,295. And now if I want to just use the zeros to solve, I could just subtract 3x and subtract 2,295 from both sides. And that would be some good practice anyway, because like I said, we know we're going to have to do that on the test. We had times when they gave us the zeros and said, write a polynomial function in standard form. So x cubed minus 5x squared plus 3x minus 2,295 equals 0. Now, we would punch it, and we would try to figure out how old are we talking about for Amir, and then using Amir's age, find the others. All right, so y equals, clear this stuff out, and let's get in that big long polynomial function we had there. X cubed minus 5x squared plus 3x, not minus 3x, plus 3x minus 2,295. X cubed minus 5x squared plus 3x minus 2,295. All right, so now, because we moved it over to one side, we know x stands for their age. If we leave this as it is right now, we're saying they can be from negative 10 to 10 years old. That doesn't make any sense. So 0, 2. Well, I mean, we could take a chance. Most people don't live to be 100, right? Give that a try. Put 100 on there, graph it, and we're looking to see, does it hit the x-axis? Ah, it does. And if 100 is over here, this looks like maybe they're in their 20s or 30s. So I'll go back and put my window to 30 just to get a better look at where that answer is at. And we could just sit here and we could count and we could get them. But you know what? I won't have to go too far in the table to find that either. So second table, let's see when we see a 0 in the y column. There it is. Amir is 15. Amir is 15. So let's go back and figure out what everybody else is then. All right, so Amir is 15 years old. If Una's 2 years younger than him, How old Una? 13. And if Stacy is 1 year younger than Una, how old is Stacy? Now, again, you could put this in as y sub 1 and put this in as y sub 2. But if you do that, you have no idea how to set your window. Because with the 0 on one side, we have x as the age. And it's easy to figure out. Oh, I'm sorry, I didn't realize it was just right now. Which makes it a little harder to find it with the window. But you could. Y sub 1 and y sub 2. Alrighty, let's try the got it for this one. I actually kind of like the got it because it's a little bit easier. If you understand what this means, what are 3 consecutive integers whose product is 480 more than their sum? Okay, consecutive integers. Back in geometry, you talked about consecutive angles. Anybody remember what consecutive means? It means one right after another. So if we say that our lowest integer is x, how many r's? Integer. There we go. So their numbers like 3, 4, and 5. So if this is my lowest one, how do I get to the next one? How do you get from 3 to 4? You add 1. How do you get from 3 to 5? You add 2. Those are consecutive integers. So x, x plus 1, and x plus 2. What's product mean again? Finding a product. What is it? Multiplying. So x times x plus 1 times x plus 2 is 480 more than their sum. What sum? Add them all up. And then, like it said, you're going to need an additional 480 on there because the product is more than the sum. Again, you could try. All of this side is y sub 1. All of this side is y sub 2. But you are going in blind for your window if you do that. It really is easier if you just do the FOIL, distribute the x, and then go over and do the addition on the other side. And then you can bring it all together. X plus x plus x, 3x. 1 plus 2 is 3. 3 plus 480 is plus 480. All right. Bring it over to one side. Oh, I forgot to write 3x. So let's subtract 3x and subtract 483. And we will have x cubed plus 3x squared minus x minus 483 equals 0. Get everything over on one side. All right, it's calculator ready. Let's get it in there. Y equals clear, and it was x to the third plus 3x squared minus x minus 483. Okay, so window. The product has to be 480 more than their sum. Well, they can't be that big of numbers. I mean, if you take 7, I'm just thinking like 8 times 9 times 10, that's already at 720. So maybe if we just keep our window at the same window that we had for the other one, we'll be okay, 0 to 30. We'll see. Yeah, there's our answer right there. 1, 2, 3, 4, 5, 6, 7. second table. I'm just going to make sure that it's 7, it says 0. So the first number is a 7. So if the first number is a 7, and they have to be integers that are right after one another, what are the other two going to be? What's right after 7? 8. What's right after 8? Yeah, 57. There we go. So 7, 8, and 9. We'll do that. So we had finding the zeros by the calculator, and that really was the theme all the way through for our objective. How do you feel about finding zeros using second trace zero? Give me your 4, 3, 2, 1, 0. Tired? Yeah. Paying attention to where to hit these buttons. So you're feeling pretty good about using the calculator, huh? Most people have some pretty good numbers here. Okay, good. Good, good, good. So, I have this little bugger for you. Not much there, but it is some practice on finding the zeros with your graphing calculator. Oh, Blinky does it for you. Blinky's not open. Well, he's trying. Yeah. Don't follow, don't. Follow directions. I need you to remember how to factor cubics. So do follow the instructions. Follow the instructions on this one. I'm just afraid that maybe over the weekend, maybe somebody forgot our formulas for factoring cubics. Maybe not. Maybe every single one of you remembered. Do you remember? What is it? A plus B, A squared,
plus AB,
minus AB. All right. You guys got a memory like a safe. Excellent. Excellent. That's the one I was worried about. You start forgetting. It's locked in there. It's not coming out.